Hello friends, welcome to Susan and John MathTube. In this video, we continue finding radius of curvature. Okay, in the last video, we discussed what is curvature and we learned two formulae for curvature, one for Cartesian and one for parametric. And we did two very simple problems in the first video. Okay, now let's start with the next question. You can write, find the radius of curvature for the curve y is equal to c cos or cos hyperbolic x by c, and show that the radius of curvature is same as y cube divided by c. Okay, look at this. You can read this as cos hyperbolic x by c or cosh. Actually, the hyperbolic functions are nicknamed as the drunken functions, or it's kind of like we drink alcohol and we learn trigonometry. We'll be kind of like reading sine as shine, cosh, dan, shake, koshake and koth. And if you look at the books or the dictionaries, you'll see that this is a proper way of pronouncing the hyperbolic function. So I'll repeat, if you want, you can read this as kosh, shine, koshake, sheik, dan, etc. etc. Now if you don't want to be funny in the class, you can simply read this as cos hyperbolic x by c. Okay. Anyway, in class 12, I'm sure that you learned the derivative of cosh is shine and shine is cosh, and this is clearly Cartesian, so I'll write the formula. Radius of curvature at any point is given by rho is equal to 1 plus y1 square by to the power 3 by 2 by y2. So the first derivative will be c into shine x by c multiplied by 1 by c. Look at this. This is not cosh x. This is cosh something. And whenever you have cosh something, you are supposed to apply chain rule. So cosh something becomes shine the same thing into 1 by c. So y2 will be again cosh. Okay, time to plug in. This is actually a part of the question. We can write y2 as y by c times 1 by c, that is y2 will be y by c squared. Okay, now time to plug in. So the radius of curvature will be 1 plus shine squared x by c the whole power 3 by 2, the whole divided by. Now look at this. In trigonometry, we have the formula cos square theta plus sin square theta is equal to 1. But in hyperbolic, the formula is cos square theta minus sin square theta is equal to 1. Or in other words, 1 plus sin square theta is equal to cos square theta. So the numerator becomes cos hyperbolic squared x by c the whole power 3 by 2, the whole divided by y by c squared. Now in the last video we discussed about laws of indices, and again you can see that cos x by c. Look, in the question it is given cos x by c is y by c. So we end up with y cube by c cube the whole divided by y by c squared, and that will give rho is equal to y and y will get cancelled, y square by c. That's it. So please write find the radius of curvature. I want all of you to do these problems along with me. Then only you will be benefited. If you are just watching this video as a movie or a documentary, it won't help. If you want marks, you have to practice these problems along with me. Even that is not sufficient. After that, you take any reference book you like and practice a lot of questions. And you can take your past year question papers and practice questions from there. So only if you practice a lot, you're going to get marks. So keep that in your mind. Okay, so please write, find the radius of curvature at the point a comma 0 for the curve y is equal to x cube into x minus a. Clearly Cartesian equation. So we write the formula, radius of curvature at any point is given by 1 plus y1 square the whole power 3 by 2 the whole divided by y2. Now look at this, y is equal to, let's distribute this x cube. So we get x power 4 minus a into x cube. So y1 is equal to 4x cube minus a into 3x square, and y2 is equal to 12x square minus a into 6x. Now look at this, here we want radius of curvature at a particular point. So I told you in the last video itself, I told you there are two options. If you want, you plug in y1 and y2 directly into row, and finally you plug in a comma 0. Or you can do another method. You can find the values of y1 and y2 at a comma 0. That will be more easier. So y1 becomes 4a cube minus 3a cube. That will be a cube. And y2 becomes 12a square minus 6a square. That will be 6a square. So that's it. Time to plug in. So you can write the radius of curvature at the point a comma 0 is equal to 1 plus a cube the whole power 3 by 2 the whole divided by 6a square. So that will be 1 plus a to the power 6 by 6a square. So that's it. Okay, now another question. That's an implicit function. So please write, find the radius of curvature at the point 3a by 2 comma 3a by 2 on the curve x cube plus y cube equal to 3axy. Okay, so the difference is, this is not parametric, this is still Cartesian equation, but it is in implicit form. Implicit form means x and y will be mixed up. You can think about the last question or the questions which we did in the previous video. Everywhere y was given as a function of x. But here you can see that all the variables are mixed up. Anyway, we start as usual. The radius of curvature at any point is given by 1 plus y1 square the whole power 3 by 2 the whole divided by y2, and put it in a box. Okay, the next thing to do, we have to differentiate this. So this problem will be little bit difficult compared to the previous questions, because it's not about the first derivative but about the second derivative. Yeah, anyway, let's give it a try. So 3x square plus 3y square into dy by dx, because we are differentiating with respect to x, and that will be 3a. I will use some colors. X, are you able to see x multiplied by y? So it goes like x into dy by dx plus y into 1. So you can see that 3 is common throughout the expression, term by term. It's kind of like dividing throughout by 3. Now let's distribute this a. What we do is we keep terms with dy by dx on the left. Now dy by dx comes common, and finally we get ay minus x square by y square minus ax. So we put it in a, okay, we will not put box. Okay, now comes even hard work. We have to find the second order derivative. So d square y by dx square. So start denominator. I want you to differentiate the numerator. A into dy by dx minus numerator into derivative of denominator. The whole divided by denominator square. Okay, one advice that I want to give you is, in this question, they didn't ask the radius of curvature generally. They are asking you, what is the radius of curvature at a particular point 3a by 2, 3a by 2. And in such problems, I will ask you not to simplify this expression too much. This is enough. This is enough. Because we are soon going to plug in all the values. So wait a minute, I'll show you how. So now I'm going to write at the required point 3a by 2, 3a by 2. Now let's plug it inside our y1. So what will we get? A into y coordinate. So 3a squared by 2 minus squaring the x coordinate. The whole divided by squaring the y coordinate minus a into x coordinate. Okay, you can see the numerator and denominator are like what you call a minus b and b minus a. So definitely this will give you minus 1. No need to waste your time simplifying. It's going to be minus 1. Okay, now comes a very like what you call hard job. That is, you have to find the value of y2. And I didn't simplify, I told you, because we are going to plug in this value. So y squared means 9a squared by 4 minus 8 times x, 3a square by 2. A into dy by dx means we already know what's dy by dx, so minus a minus 2x, that will be 3a, because 2 times will cancel this, minus ay. Okay, now ay means 3a square by 2 minus x squared into 2y dy by dx. How much? 2 into y coordinate will be 3a into minus 1, because dy by dx is minus 1, minus a, the whole divided by y squared, and this will also become minus 4a. And I'm going to make this positive. Okay, now I'll make this positive by reversing the term. So basically I'm going to get what you call this and this to be same, but I'll use that minus also. So basically we are going to get 9a square by 4 minus 3a square by 2 Okay, and on simplification, I'm not going to waste your time. You can try to simplify. You will get minus 32 divided by 3a. So that's it. We got y1 as minus 1 and y2 as minus 32 divided by 3a. Again, all these values. So the value of rho at 3a by 2 3a by 2 will be 1 plus minus 1 the whole squared, the whole power 3 by 2, the whole divided by minus 32 by 3a. By the way, you might be wondering why we are getting radius to be positive. Actually, many authors write the formula of radius inside a modulus sign. Radius cannot be negative. So, if you want, you can avoid that negative and make it positive. But the reason is because of the bending, because of the convexity and concavity of the curve. Because we cannot maintain the same sign on both sides. So, the sign actually shows whether it is convex or concave. That's why you end up with that negative. Because you have learned that convexity, the bending of curves are decided by the second order derivative. The first order derivative gives you the slope. The second order derivative gives you the bend in a curve. So if the bend is negative, then it looks like this. And if the bend is positive, it will be an upward bend. So that is why you got that negative, because of the bending effect. Anyway, when you write the answer for radius, it should be written as a positive number. And finally, you get 3a by 8 root 2. Please give it a try. I skipped a lot of steps, but you can give it a try. Let's go for another question. Okay, that's very interesting. Find the radius of curvature. Find the radius of curvature of b square into x square plus a square into y square is equal to a square into b square, where it meets the y-axis. So look at this, we have to find the radius of curvature, but the point is not specified. They said where the curve meets the y-axis. Do you know the speciality of the y-axis? If you look at the coordinate of any point on the y-axis, you will notice that the x coordinate will be always 0. So the curve meets the y-axis when x equal to 0. That is a square y square, because 0 plus a square y square equal to a square b square. That is y equal to plus or minus b. So where does the curve meet the y-axis? So one point is 0 comma b and another point is 0 comma minus b. Okay, so let's go for the derivative stuff. So b square into x square plus a square into y square equal to a square b square. This is an ellipse actually. So let's differentiate. They have given the equation in implicit form. So b square into 2x plus a square into 2y dy by dx is equal to 0. So dy by dx will be minus b square into 2x a square into 2y, so that gives you this. Now we will find that later. So let's write y1 is equal to b square by a square x divided by y. Second order derivative means we have to apply u by v rule. So denominator, derivative of numerator minus numerator, derivative of denominator by denominator square, that will be minus b square by a square. I think we should not simplify because it's at a particular point, right? Now let's write at b 0 comma b y1 is equal to how much? 0 by b is equal to 0. Now y2 is equal to b minus 0 by b squared is equal to minus b by a square. Now time to plug in radius of curvature at b. 1 plus y1 square the whole power 3 by 2 whole divided by minus b by a square. So the answer will show up as, but remember this negative comes because second order derivative shows the bending, the convex concavity. So the bending is negative means you know our ellipse, right? And you can see that there will be negative bending here. That's why we get the answer as negative. But radius being a positive quantity, the formula actually comes inside a modulus, so it's positive. See, it works. The bending is negative. Now we have to calculate at the other point. So at b 0 comma minus b, the radius will be something similar. You give it a try. Anyway, the answer is a square by b. Now let's go for another very important question. Please write. Find the radius of curvature for the curve root x plus root y equal to root a at the point where it cuts the line y is equal to x. So the questions have become more interesting. Instead of giving a point, they are asking what is the radius of curvature of this particular curve at the point of intersection of this line and the curve. Okay, so the first thing to do is to find the point of intersection. Do you remember how to find the point of intersection? Very simple. Solve the two equations simultaneously. It's very easy to solve. You can see that the y value is x. So basically we get root x plus root x is equal to root a, or 2 root x is equal to root a, or squaring gives us 4x is equal to a, or x is equal to a by 4. Now look at this. At the point of intersection y and x are equal. So I can write, therefore required point or point of intersection is a by 4 comma a by 4. Okay, once more I'll read the question for you. Find the radius of curvature at the point a by 4, a by 4. Now this is a familiar question for you. It is an implicit function. I'll repeat, this is an implicit function. So be very careful when you differentiate. What is the derivative of root x? It is 1 by 2 root x. So what is the derivative of root y? 1 by 2 root y into dy by dx, because we are differentiating with respect to x. And of course, a being a constant, we are going to get 0. So dy by dx will be, this goes to the other side, minus 2 root x. Now for y2 we have to apply u by v rule. So denominator into derivative of numerator minus numerator into derivative of denominator, the whole divided by root x the whole squared. Okay, that's it. I told you, whenever they give us a point, it's better not to simplify this. So let's find what is our y1 at the point a by 4, a by 4. What will be that? Root a by 4 by root a by 4, we are going to get minus 1. Okay, I'm happy. I'll color it in blue. Okay, now let's plug this into our y2. So root a by 4 by root a by 4, this will get cancelled. So we get 1 by 2 and dy by dx is minus 1, we calculated now. Minus this will get cancelled and again 1 by 2. The whole divided by x coordinate is a by 4. This will be, use a calculator, it's going to give you 1. So 4 by a. So that's it. We got y2 is equal to 4 by a. Let's color it in blue. Okay. So what's the formula? What's the formula for radius of curvature? Rho is equal to 1 plus y1 squared. The whole divided by 4 by a. I told you something to the power 3 by 2 is actually multiplied by a by 4. So if you want, you can leave the answers like this, or you can simplify and put it like, because this is 2 into root 2 into root 2. So that's it. Okay, the video has become already long. So in the next video, I'll be back with problems related to parametric form. So I hope you got a clear concept of radius of curvature in Cartesian form. So soon we will start parametric form, and later on we will move on towards polar and pedal equations. So till then, my friends, bye.